this video, we're going to do factoring. And I want to call it day one because this is a review of all the basic factoring, from GCF to difference of squares and factoring mentally. This is not the first time you've seen it, so it's just a review of everything that we've done so far. So before anything else, you're always going to look for the GCF, the greatest common factor. So example one, what do they have in common? Well, the GCF is something I can divide them both by and still get a whole number. So between 25 and 30, the GCF will be 5. Now notice that they both have y squared. So that's going to go on my GCF. So that means at this point I can divide both terms by the GCF. So the GCF doesn't disappear. Okay, it's part of your final answer. So the GCF goes right there in the front. So 5y squared. Now you're going to divide, and whatever you get, it's going to go in parentheses. So 25 over 5 is 5. Y cubed divided by y squared is y. So minus 30y squared divided by 5y squared. Y squared divided by y squared is 1. 30 divided by 5 is 6. So when you're factoring, you're just rewriting that, but in a different way. So when you're pulling out the GCF doesn't go away. Now, if the first term, that number in the front right there, if the first number is negative, then you have to factor out the -1. So that means you're going to divide every single thing by -1. Okay, so what else do they all have in common? Well, so when I'm looking for the GCF right here, I know the leading coefficient right there. So the first term is negative, so I have to factor out the negative. What else? Well, I can divide them all by 2, and they all have x. Okay, so that's the GCF. So you will divide every single term by the GCF. Like I said in number 1, the GCF doesn't go away. The GCF goes right there in the front. And then when you're dividing, you're going to put everything you're dividing right there in parentheses. So -6x cubed divided by the GCF. So -6 divided by -2 is 3. X cubed divided by x, you get x squared. Because you're subtracting the exponents, remember that? So there's an invisible 1 right there. So -4 divided by -2, you get +2. X, 8 divided by -2, you get -4. X divided by x is 1. Okay. There's nothing else I can do right here to keep factoring. So this is my final answer. As soon as I pull the GCF out, I'm already factoring. Now, if you have only 2 terms, I have to check for difference of squares. What does that mean? It means the first term has to be a perfect square. The second term has to be a perfect square. And you have to have a minus in the middle. That's why it's called difference of perfect squares. Okay? And how you go from here to here, you take the square root of the first one, you take the square root of the second one, and 1 is plus, 1 is minus. What does that look like? Okay, 4x squared is a perfect square. Y squared is a perfect square. And you have a minus in the middle. Therefore, example 3 is a perfect square. So take the square root of 4x, 2x. Take the square root of y squared, it's y. Okay, 1 is plus, 1 is minus, just like that. That's all you're doing there. All done. Beautiful. Now, 5 is not a perfect square. 12 is not a perfect square. I don't have a GCF here either. So when you cannot do anything, that means it's prime. You cannot divide, that's prime. Now, easy right here. If you have 3 terms and the leading coefficient is 1, that's when you factor mentally. What does that mean? You're looking for 2 numbers that multiply to -14. And same 2 numbers that add up to -5. So when I look at -14, I know one is going to have to be negative and the other one has to be positive. So when I'm multiplying, they have different signs. I get a negative number right there. Okay? So when I add them together, the number right there in the middle has to be -5. So how about 7 and 2? Well, -7 times +2 that will give me negative 14. Negative 7 plus 2, that gives me negative 5. Okay? Now, if you don't know your times table, that might be a problem. So the way you're going to write your answer here, and you know your numbers will be negative 7 and 2. How do you write the answer? So x minus 7, x plus 2. Done. This one, I like when they're all positive because I know there's not the tricky negative right there just to mess me up. So when I think of 36, I think of 9 times 4. I think of 3 times 12. What else? 2 times 18. But I'm looking for the one that adds up to 15. Okay, and in this case, they're all positive. So positives are my friends. So 9 plus 4 is not 15. 9 plus 4 is 13, so it cannot be this. 3 plus 12, oh, look at that. That's 15. So my two numbers will be 13 and 12. So x plus 3 and x plus 12. Okay, 3 more. Now, the next 3 examples, we're going to put them all together. All the skills that we just reviewed, we're going to work it all together. Always start out by pulling the GCF out. So GCF right here, I can divide them all by 3. When you're dividing all by 3, you have to divide all 3 terms by 3. The GCF doesn't go away. That doesn't disappear. So the GCF goes on the outside. You're dividing 3x squared divided by 3. You get x squared. 24x divided by 3, 8x. 45 divided by 3, you get 15. Now, the leading coefficient right here in parentheses, I have 1. So I will factor mentally like we did for number 5 and number 6. So for number 5 and number 6, I was looking for 2 numbers that multiply to 15 and same 2 numbers that add up to 8. So good thing they're both positives. So easy money right there. So 3 times 5 is 15. 3 plus 5 is 8. Double check one last time. There's nothing else I can do to keep factoring. So when you cannot factor any longer, you're done. Now number 8, the leading coefficient is negative. So from example 2, when the leading coefficient is negative, you have to factor that negative out. So I know my GCF right here will be negative. I can definitely divide them all by 5, and they all have x. So that's the GCF. GCF doesn't go away. GCF goes right there in front. This divided by this. So I have just simply x squared. 50 divided by negative 5, I have negative 10. X squared divided by x, I have x. 120 divided by 5, I have 24. Okay, and x divided by x is 1. Now I have to keep factoring here. GCF doesn't go away, so that negative might be tricky. So be careful. I know 2 and 12 multiply to 24. But those 2 numbers, they have to add up to the one in the middle. They have to be negative to add up to negative 10. But negative 2 and negative 12 added together, that's negative 14. So that is not 2 and 12. Okay? But I do know negative 4 times negative 6, that is positive 24 when I multiply them. So when you add them together, you get the beautiful negative 10 that you were looking for. So x minus 4, x minus 6. Be very careful with the negatives. They will trick you. Okay, last one. GCF, right there, I can divide them both by 5, and there's nothing else I can do there. Okay, so GCF doesn't go away. GCF goes right there in the front. 125 divided by 5, 25, x squared. 80 divided by 5, 16. All right, now, if I box it up, I didn't factor that completely, and that's a very common mistake there. So 25 is a perfect square. 16 is a perfect square. I have only 2 terms, and I have a minus in the middle. Ta-da! So go ahead and check for difference of squares. Okay, they're both perfect squares. Now, you need to know your perfect squares by heart, so you're able to recognize when you have difference of squares right there. So GCF doesn't go away, and this is a case of difference of squares right there. So you square root 25x squared, you square root it, you get 5x, you square root it, you get 4. Just like from the formula right here on top, one is plus, one is minus. There's nothing I can do to keep factoring. Therefore, you are done. I hope this helps.